My name is Nick Butcher. I'm an Android engineer at Google.
I'm Chris Baines, and I'm also an Android engineer at Google.
And we've got a ton that we want to tell you about today, so we're going to crack straight into it. So themes and styles. Hopefully everyone is in this room because they're familiar with it. The theming system in Android has been around for a long time. Most of it has been there since API level 1. It's actually stood the test of time reasonably well. But that's not to say it isn't without its limitations and some bad practices that I think have developed because of them. Firstly, hopefully everyone is... Oh, can we have some slides, maybe? Possibly? Hey, how about that? Cool. OK, so let's go back. There we go. So everyone's hopefully familiar with a style definition like this. One of the problems, I think, with the style definition like this is that, well, firstly, there's only one of them. You can only apply a single style to a given view. Unlike something like CSS, for example, which allows you to define multiple styles and enabling you to kind of like factor things out into like reusable, composable chunks and do some kind of like mix-in type behavior. You can't do that. Secondly, it's kind of largely untyped system. So you have this kind of XML declaration, and you can put pretty much anything inside it, like any item, and there's going to be no type checking or anything like that. You kind of just have to try stuff and see what works in a way. And it doesn't really help you very much about what you can put in there, what you should put inside a style. I mean, ideally, like if you're talking about API regret, I wish that something like this had existed, that there was a separate tag for a theme than for a style. But unfortunately, that's a fairy tale that doesn't exist right now. So as such, we had to work around the fact that this kind of like untyped system that we have and try and enforce the typing in different ways. So a lot of this comes down, I think, to really understanding how the system works, so that you can wield it properly, so that you can use it throughout your applications, so that you can make your styles and themes manageable, so you don't end up with an explosion of hundreds and hundreds of different styles and themes that you just don't know how to use or how to work with. We're going to give you a bunch of tips and tricks to understand the system and then how to apply them to your applications. So first up, let's understand themes and styles. So as I said, a style definition looks something like this. And I really want to focus in on the fact that it's basically just a key value store. Both styles and themes are basically configuration stores where you can stuff some configuration to be referred to or applied to a view or something later on. And for me, I think the first thing you need to understand is the difference between a theme and a style. Like I said, they both use the same style XML declaration, but they are different things, and they should be used differently. The first thing I think to understand is that the key, if you think of them as a map of these keys to values, the key types are different. So in a style, the key for the keys are all view attributes, so things you would declare in your layouts to set attributes of views. Whereas in a theme, the keys are theme attributes. So for example, here is a common kind of widget style, and you can see here that each of the keys here are these things that we would set on a view, and the values are resources. They point to resources in the resource system. And hopefully everyone is familiar with the resource system. There's many different types of resources that we can have, which are all listed out here. Themes, on the other hand, the keys in which are theme attributes. And I think understanding theme attributes is one of the keys to understanding the differences between styles and themes. So a theme attribute is declared a bit like an attribute you would for a view, in that it's given a name and a type. But really, the way to think about theme attributes is like semantically named variables, which you can declare and then separately supply different values for different themes. So in this example here, in a theme, using one of these theme attributes, where you do so by using the question mark atra syntax. So question mark here means for the given theme that's applied at the moment, please grab me the current value for this semantically named thing. So the current value for color primary, for example. What's cool about that is it means you can do it enables you to kind of clean up your styling and theming like a lot. So for example, a library like app-compat or material components, for example, can define one of these theme attributes. It can declare a theme attribute like color primary. And then later on in your application, you can supply a value for that. So it separates the kind of the declaration from the value being supplied. And what's cool about that is, say you have a different area of your application, like a pro screen or something like that, which wants to have a different visual look and feel, maybe a different color scheme. You can provide just a different value for that given theme and use the entirely same widget set, which refer to that same semantic value. And what's more, say you want to support dark theme, then you might want to provide a different value for that color when running under a night configuration. And as such, you can just provide the different colors for where they want to be different. But you don't actually have to provide, like, say you were trying to achieve that with a style. You'd probably end up defining a style for each widget, like in each of those circumstances. So you'd have a style for a button, a style for like, the dark button, a pro dark button, for example. And each of these would probably be like 95% the same, but you're probably just changing, say, the background drawable to change to a different color. And because styles only apply to a single widget or a single widget type, you'd probably end up with many of these. You'd end up with this kind of like combinatorial explosion of styles, which is going to become massively unwieldy to maintain, or heaven forbid, say you want to change your brand color. That's going to be like a huge piece of work. Versus isolating the change that you want to make just to that semantic variable and just redefining it in the different places keeps it much more focused. So going back to those keys for the different maps. So view attributes are the configuration specific to a single view, and theme attributes are these semantic variables which are varied or provided by the theme, and they can be used much more widely. So hopefully that helps you to think about the difference between a theme and a style, like what they are, the kind of their types, but also how you use them, how you apply them in your application varies slightly as well. So styles are one-to-one with views, so they're associated with a particular view type, as in the keys that are kind of only like valid for whatever widget they're applied to, the view attributes that widget has. Versus a theme is actually associated with a context, and it applies to a hierarchy and overlays any ancestors. Let's look at what that means. So say I have a hierarchy in my application like this. If I were to set a style on any view in the given hierarchy, it's just going to apply to that one that view, and that style has to be appropriate for that view type. Contrast that to a theme. If I were to apply a theme to a particular view or view group, that will actually kind of cascade down to the descendants, and any of the descendants will have that same theme applied. And you do that using the kind of Android theme tag like that. And when I say it kind of applies over the top of any other theme, there's always some parent theme to whatever theme you apply to your application. So that could be, say, at the activity level or even at the application level, will always be a theme applied. So when you apply that theme to that sub-hierarchy, it's going to take the theme that was already applied and overlay this on top. So this can be really useful for doing something like this. So this is a screen in an application where it's kind of got this kind of pinky theme going on. But if you scroll down to the bottom, it's got this link out to like a related article section, which is using the theme of that destination, which is kind of this bluey theme. So this is like really easy to achieve using this kind of like theme overlay approach, because you can set a theme on this sub-hierarchy, and any views contained within it will then benefit from that new theme. So you do it something like this, where you specify the theme maybe at the root of the fragment or on the activity would be like that blue theme, and then the pink theme, sorry, and then at the root, the view group, the further down the view group, you would apply just that overlay, the blue one that you want to change. So there's quite a few things going on with themes. So I think this overlay idea needs to be understood, how themes are overlaid on top of each other. So in the screen, there's a couple of themes going on. So the first theme declares a few things its own theme. It might set up some colors and so on like that. But it's going to inherit from a parent, something like material components light, which is going to then set up, it will define a lot of stuff in its theme, so things like some default styles for some widgets. That's going to inherit from something like app-compat, which it does a bunch more stuff, which will then inherit from a platform theme like material, which is going to define pretty much everything else for your application, right down to things like as specific as like the drawable to use for a cursor. If you apply a full theme as this kind of overlay idea on this kind of sub-hierarchy, there's two things going on here which are a waste. First off, a lot of these attributes are going to be the same between the theme we're overlaying and the new theme being applied. So it's kind of wasteful in a way to kind of like load up the kind of text cursor drawable again, just to kind of replace it with probably the same drawable. And secondly, any specific theming in the activity level, like something in that theme.al.pink that we wanted to keep, is probably going to be replaced by anything in this sub-hierarchy theme we're playing. So what the idea here is that you can use a technique called theme overlays instead to avoid this problem. So a theme overlay isn't a new type or anything like that. It's just really a technique that you can use in your applications, where the key thing really is that you have no parent to the theme. So basically, rather than being a full theme inheriting from material components or app-compat or so forth, you explicitly just say that this has no parent, and you just provide the values that you want to change. And as such, when you apply that to the hierarchy, when you set the Android theme to this theme overlay, you'll retain everything from the ancestor theme that was set further up in the hierarchy, and you'll just change those things that you want to be different. And a tip here is there's a couple of theme overlays that if you just want to toggle between, say, a light appearance and a dark appearance, like theme overlay.materialComponents.dark and .light and so on, are useful to use. Another tip on when, a consequence of this overlay behavior is that quite often I see something like this, where someone is using, something like context compat to load a color, but they're using a context that they have around from, something near the root of the hierarchy, like say the fragments context itself. Instead, what you want to do is you want to use the closest view to where you're going to apply that color, because as such, remember a theme is associated with a context, and they get overlaid. So if you use one from too high up, then it won't have any theming that you overlay in your hierarchy later. So this is kind of like a landmine. If you're using the wrong context, and you're then trying to apply a theme at some point later, and you're trying to reference a color or something, then you might end up with the wrong value. So try and use the closest possible context when loading something like that. Or better yet, try and work with theme attributes as much as you can. So rather than loading colors like this, like the context compat, do something like this, where you're actually querying a semantically named color from your theme. And if you need to recreate this kind of overlaying behavior in code versus setting the Android theme on a view group or view, then you can do so using a context theme wrapper, which is essentially what it will do under the hood anyway. So in the context theme wrapper, you provide a context and you wrap it with a given theme, and it will do this applying on top behavior for you. And then you can use that theme context for something like a layout inflator to inflate stuff. Cool. So hopefully that teases apart the difference between the types of a style and a theme and how they apply to views and so forth. I think there's another thing that's interesting to understand about the style system is how it's resolved, by which I mean that we've seen that there's different ways that you can supply values for view attributes. For example, you could set, say, the background directly on a view, or you could say set it in a style which declares that background value. What's going to happen there if you declare both of them? Well, the answer is that the one closest to the view, so the one in the layout, is actually going to have a higher precedence and be applied. So here we'll end up with a green background rather than the blue one from the style. And the reason why is if you look at any of the style system, it basically always ends up in a call to this, to context.obtain styled attributes, which is given everything from your layout and your style that you declare. And it resolves, this is the thing that's responsible for resolving them down to final values. And it has some precedence rules, which I think are important to understand. So we just saw the first one, that anything that's declared in a layout on the view itself will override anything defined in the style. There's actually a few other places that this system will look when resolving view attributes. The next one is any default style, which is associated with the widget type. I don't think many people are using default styles that much, so I want to run through the concept of it real quick. To do so, why does a button look like a button? Why does it have a certain background, a certain text transformations, all caps, a certain alignment of the text, and so on? If you look in the the widget, the button class, it's actually very, very thin. There's barely anything in it. It's an extension of text view. But it does this one thing. In its toArg constructor, it calls super on the view class, passing this value here as the default style attra, which is basically saying, look in the current theme for a theme attribute with this name and load the view attributes from that, unless they're overridden by something with higher precedence. So if we look at something like the material theme, it defines this theme attribute we just talked about, a button style theme attribute, and points it towards, on material, this material light button style, for example. And that will be the style that defines all those view attributes you see by default. So when you just drop a button in your layout, you get some default behavior. So but it's not just the platform themes or material components that can use default styles. I highly encourage you to use them in your application. So say you want to set all the toolbars to have a certain look and feel. I think a better approach is to do it using a default style like this. So in your theme, you declare a toolbar style and point it to that style that you want for all your toolbars, rather than trying to remember to set a style on each individual instance of it. As such, like styling becomes opt-out. So if a new person joins a team, or you make a new screen, or you refactor, you don't have to remember to add the style that you want your toolbar to have. It becomes by default, you'll get it, unless you want to try and change it to something else. Another tip of something I see a lot of is if you're extending a view class and making a subclass. Say here, for example, I'm making some kind of custom text view, which is extending app.compat text view. I see people often just passing 0 for the def style attribute. What this is going to do is it's going to override, it's going to clear the parent's default style. So app.compat text view uses the platform's text view style. And as such, if you pass 0 for this, then you're going to get rid of that behavior. So anything that comes from the default style, you won't get in your custom subclass. So you want to be careful about passing 0. Check the widget you're extending to see if it declares a default style attribute, and if so, use the same one. Cool. So that was the 3 levels thing. And there's one more place that obtained style attributes will look, and that is in the theme. So when I said earlier on that the keys for a theme are theme attributes, that was a little white lie. You can actually put a view attribute in there as well as a perfectly valid key for a theme. So here's a ridiculous example where if in your theme you set the background in the theme, the Android background, which is a view attribute, to a value, so here like a magenta color, then every single view in your application, which doesn't itself override it with a higher precedence level, will get this hot pink background. So that sounds silly, but it can actually be useful. So for example, if you're implementing dark theme, the Android Q added this attribute called force dark allowed, which is a view attribute on the view class. So rather than going through every single view or every single default style for widget and adding this to true, you can actually just set this in the theme level, and it will apply throughout, and then just turn it off for particular views where you don't need this behavior. So to understand, so that was the precedence order for styling, which I think is pretty important to understand. So just to sum up the kind of difference between themes and styles, styles are really good for keeping your layouts dry, for don't repeat yourself. So if you have different styles, say 2 different, a red button and a green button, which is used throughout your application, that's a perfect candidate for a style, because it's the same type of view. Versus something which is going to be applied across a bunch of different views, something like color primary. Here color primary is used across the different widgets, and when you change it in one place, you want that effect to kind of ripple out beyond to many different types. So that is what a theme is really, really great at. So quite often I see people doing something like this, where they want to get a blue button, and they know they need that blue color is controlled by the color primary. So they try and do something like set a star, which sets the color primary, which just kind of doesn't really make sense, because essentially that's trying to set color primary view attribute, because that's what styles set, view attributes, on a button. And there is no color primary view attribute on button. What you should be doing is be setting a theme overlay, which then itself then changes the color primary to it. So essentially, I like to say, don't bring a style to a theme fight. So you can't use a style to set a theme attribute and vice versa. So just know the difference between them so that you can spot when you're kind of trying to use them wrong. So hopefully that's kind of teased out some of the differences between themes and styles. But I've kind of tried to show the differences. But in reality, they work best when they're used together. So you can and should query theme attributes in your styles, and you should set theme attributes which point to styles as well. Cool. So that was some fundamentals about the difference between themes and styles. Let's see how we actually use them in our apps.
Thanks, Nick. So for me, the most important kind of resource you have in your apps are these. They're colors. They make up the most of your theme, and they're the thing that define what your drawable tints and stuff like that. So when we look at colors, there are a number of ways to define them in Android. The most common way is to have an RGB value like this, using the color tag. Now this is made up of RGB, or optionally you can also have an alpha component if you need it. Now actually Android Studio has some great tools around colors. So when you have your resources, you'll see a little color like representation, like a box, showing that color. If you click on that, you'll get this drop-down box. And it has 4 great tools. The first one is that you can easily change the alpha component of the color using that slider. The second is that you can actually change the color itself in HSB format. And that allows you to easily do stuff like change the saturation or the brightness. The third one is that it actually has all the material color palettes built in. So if you just want to grab a color, say gray 800 or whatever it is, you can easily just grab it, click on it, and it will automatically populate the color. And the fourth one is that it actually has a color picker built in, so you don't have to use the Mac one or whatever. It has it built in. So color resources don't just have to be hex values. They can actually reference other color resources, which is quite handy if you want to create like aliases. These don't have to be in the same file. They don't even have to be in the same module. And so they're quite good for creating those aliases. The one thing you can't do is reference theme attributes. They have to be other color resources. So they're static colors. Now let's talk about color state lists. Now color state lists are wrappers around colors, which are stateful, and use the same state system as views and drawables do. So here's an example of a button. And when the user clicks on the button, if it's pressed, it turns into a gray. And then when it's disabled, it goes into this translucent gray instead. So we have a quick look at how color state lists are defined. It's via the selector tag. And each item within that tag are one of the states. So if you look at the first item, it has a state of state checked equals true. So this will be selected when this checked state equals true in your view. And then the item at the bottom is the default state. That has no states. It's just item, which means it's the default color. It's like the fallback color if nothing else matches. So one tip for color state lists is always to order them from most specific at the top to least specific at the bottom. This is due to the ways the color state list class actually tries to find a color. It basically goes through each item until it finds one which matches. So it's the first match. So you always want to make it so that most specific is at the start, and so it actually follows through. If we do this instead, where we swap the colors around, so our default color is at the top, what that means is that this color will always be selected, because no state means it matches everything. So therefore, it will always be the first thing that matches. So why are colors important? Well, for me, they're the basis of good styling on Android. If you've been doing Android long enough, you'll probably remember a tool like this, where to actually change the toolbar color, the action bar color, you have to use this tool, change the colors, and then you'd get these nice 24 ping files where you'd download.
Density.
Density.
Yeah, thanks, Jeff.
So you're dragging this, whatever it is, 200 kilobytes of ping around for no real reason. These days, you get pretty much the same result using these 3 attributes. So what magic has allowed us to do this? Well, if you look at button, so AppCompat has the button.colored style, and that will color the button background based on your color accent from your theme. So here, if it's pink, it'll color it pink, green, red. And then when you change it to be disabled, so enable equals false, it actually goes to a gray color. So even though it's supposed to use your color accent, it's actually using a gray. So let's look at how that's implemented. So the background of the button itself is this drawable. So if you remove the stuff that we don't care about here, there's 2 bits that are actually applicable. You might notice this Android tint attribute. And that brings on to drawable tinting. So drawable tinting tints your drawable using a solid color, using a specified blending mode. Now, that can be stateful if you're using a color state list, or not if you're just using a hard-coded color. It was added in API 21, so that's Lollipop, but it is supported in vector drawable compat before that, and also drawable compat if you want to wrap the drawables. So if we go back to our button drawable itself, you might have noticed there's 2 colors here. We have both the tint and the fill. So why don't we just use the fill rather than the tint? What is the point here? Well, the point is that fill doesn't equal tint. They're not the same thing. So the default blending mode is called source in. So we go through some examples about what it actually does. So here we have our duck drawable at the bottom, and that is currently filled with solid white. We don't have a tint, so as you can imagine, actual duck is white still. If we change our tint to blue, it changes to blue. This is kind of what you expect. If we change our fill color to pink instead, you'll notice that the result is exactly the same. And that is because source in doesn't care about the color of the destination, the fill, only cares about the alpha. So because that alpha hasn't changed, it's still opaque, the result hasn't changed either. If we change the alpha component of the fill instead to be 50%, you'll notice that the result has also changed. If we swap where the alpha is, so we put the alpha on the tint rather than the fill, it's the same result. Now, if we add alpha to both of them, to fill and tint, what happens is the alpha components are multiplied together, and we get 25% instead. Now, that may sound all theoretical, and why would anyone do this? But it's actually quite easy to do. So here we have, in this instance, a search icon, which you'll probably use on a toolbar. Now, it's filled with solid white. Now, what you normally do is tint it using color control normal, which is an attribute the app compat and the system gives you. Now, by default, on a dark theme, that color will resolve to 70% white. So even by default, you are actually going to be referencing colors with a translucency, which means the result is going to be 70% white. Now, if we accidentally, for some reason, use an alpha, a translucent color as your fill, you'll get the same effect we spoke about earlier, where those alphas are multiplied together, so you'll accidentally actually get a 35% white instead.
This is really easy to do if your designers are giving you, say, an SVG, and you're not looking at what color they're filling it. Say they wanted to get, like, a shade of gray, and they're using like a semi-opaque white. If you just convert that SVG into a vector drawable, it'll keep the same fill color. But then if you then apply a semi-opaque tint as well, you've got to be watch out for the opacities multiplying together. So like try and use a solid fill.
So that was actually just about sourcing, but there's actually 18 blending modes available in the framework, so you can go through and have a look at them. Sourcing tends to do what you want, but you have the option. So as a recommendation, I'd say you should always fill your drawables using a solid color. So that could be black, could be white. Using magenta is actually like a hot pink or something. It's actually really good because you can easily see what drawables aren't tinted because they'll be bright pink in your app. And then you actually tint that drawable using the color you want, so color control normal, or I don't know, some branding color. So if we go back to our button background, so we go from the tint. So let's drill down into what that tint is actually pointing to. And in this instance, it's a color state list. So there are two items. The first item, the default item at the bottom is the one that produces that color. So it's the one that references color accent and gives you that red or green or whatever it is. And at the top, we have the one that changes the background color when your view is disabled. So this brings in a new feature in color state list called alpha modulation. So you can see we have that new attribute there called Android alpha. And what that does is that is a float value from 0 to 1, which will modulate the alpha component of the color and basically times them together. So here we can do dynamic alpha modulation. So here we have a disabled alpha, which is an attribute available in all the Android themes, which is roughly about 26%. So what that does is we have our color button normal, which is a gray color. And the end result is that it will set the alpha component to be that alpha. And so it basically resolves to a 26% gray color. That's what gives you that kind of alphaed out disabled button color. So for color state lists, we have that new feature. Alpha modulation was added in Lollipop. So it's API 21, and you can only reference theme attributes from API 23. So it's actually got some gotchas you've got to be quite careful about when you use it and where. Or you can choose that compat. We backported the feature, so you can just use this API and you can grab the colors from it. One tip for color state lists, because we have these new features, we can actually do stuff like this. So I can almost guarantee that in your app you'll have stuff like this, where you've copied a color, it could be, I don't know, your primary color, your accent color, and you've just changed the alpha component. And you've used that as like a scrim or somewhere in your app. And you probably have various, like multiple of these, like one at 25%, one at 50%, maybe one at 10%. Now the problem is that if you ever want to change that, the root color, you have to also remember to change all the other alpha variants as well. And so yeah, it's not great. Now, by using color state list and the new alpha feature, we can actually make this dynamic and work automatically. And so if you have a single item color state list, and we actually set the alpha to be whatever we want. So here we're replacing our 25% with color state list, and it points to Android alpha equals 0.25. And because we're referencing that theme attribute, it will automatically update whenever we change our theme. And it also works with theme overlays, as Nick was mentioning earlier. And again, we can also do the 50% as well. Repeat for any variant you have. So that kind of summarizes like drawable tinting. But where do our drawables actually live? And they tend to live in our views. And that brings us on to kind of view tinting. So the simplest kind of summary for this is that views can override the tints that the drawables they own. So if we go for a quick example here, we have a vector drawable, which is that bug icon. And it sets a default tint of color control normal. So you can imagine it being displayed in a toolbar. So if we display that in an image view, we'll get that result. It's a gray icon. But we can actually use the app tint attribute on the image view itself, and that will override the tint for that specific icon. You can also do it dynamically using the setImageTint methods on both image view and image view compat. And of course, we can reference theme attributes as well. One gotcha here with color stateless in general is that I can always guarantee you've also done this, where you've got a color resource and you're referencing that color resource as a background on a view. It's very easy to do, and most people do it as well. Internally, how that works is that when the color is pulled out the theme, the system will automatically wrap it into a color drawable. Now, the problem is that color drawable isn't stateful, so it doesn't actually work with color stateless. So we try and do this instead. So we've moved to our single item color state list, and now we're going to try and set that on our image view. Now, that will crash because color drawable isn't stateful, so the system can't automatically wrap it up for you. So what we can do to kind of work around that is by using background tint. So that's another kind of feature in View. So we're going to create a drawable, which is just a rectangle. You can reuse that in all the views you want. And then we're going to dynamically tint that on the view using the background tint variable. And that gives us that kind of same effect. So when we look at the views which are powered by tinting, it's nearly all of them. So buttons, dialogues, fab, even switches. So hopefully you're now switched on to colors and to kind of tinting to help improve your apps. We're now going to make a quick segue into organization, because I feel like this is something developers don't really know it's kind of a lacking subject. So here we have my opinionated rules on organization. There are 4 rules. The first one is to always use literal names for resources. So here we have some color resources. And I think these are actually even given to you in the default template in Android Studio. So you have color primary dark, whatever it is. And then you're going to reference these in your theme, pointing the attributes of the same name to that color. Well, that's not a very good idea. And the problem is that you're giving semantic meaning to hex code values. They don't actually have meaning. They're just representations of color. Your app is the thing that gives them meaning. So instead, you should name them literally. If you have a brand color, a brand blue, or a brand pink, or whatever it is, name them that. If you're using the material colors, those have names and numbers, they're tones, and so use those numbers. Now, the way I think about this kind of loosely is a problem that we have day to day anyway in software engineering. It's interface versus implementation. Now, what I think is that interfaces are basically our themes. We always want to reference colors from our theme, because they'll always be correct for the situation we're pulling them out of. And then underneath that, your theme is going to be referencing resources, colors, dimensions, all the other resources. But you should never really be referencing them directly. You should always go for the theme. So that's rule 1. Rule 2 is to use consistent style names. So again, the default template in Android Studio gives you a name called app theme. And then if you have a variant, it might be called blue app theme. Now, that's not great if you want to read it, especially for code review, because you don't get the meaning of the theme just from the name. Now, and the Android framework has had rules on this for a while. So instead, we have theme.appname, theme.appname.blue. And what that implicit inheritance gives you is easily be able to skim that name and work out what the actual theme hierarchy is just from the name. Same thing happens with toolbar and widget styles. So here you have toolbar, which is the style that we've created, and then we're going to have green toolbar. Now again, we should change the name to be widget.appname.toolbar, and then again the green variant. And that implicit inheritance again helps you read what the name is and what the actual hierarchy is just from the name. So we split up the name a little bit to try and work out some rules here. The way I'm thinking about it is that the first kind of block should be the style type. So theme, widget, theme overlay, text appearance. And they're like root style types, and that should be your first name. And we got the second group. And the way I think about that is your group name. So it could be your app name. Well, most apps will be your app name. But if you've got a highly modularized app, it could be your module name instead. The third type is your subgroup name. So this is mainly applicable for widgets. So each widget style you create will be specific to a widget, as Nick mentioned earlier. So this will be the name of that widget, the class name. And the last type is your variant name. Now, these could be nested, so you could have blue dot white icon or something, whatever it is. But allows you to differentiate small variant types based on the parent style, sorry. What this naming gives you is that from code review, you can fairly easily work out when things are being misused. So here we have a view which has a style, but it's pointing to a theme. Now that should be ringing alarm bells in your head, because you shouldn't be using themes as a style. And so teams could actually, but it helps in code review to actually work out when they're being misused, but larger apps could actually be creating lint rules to try and guard against this. So that's the second rule, use consistent style names. The third one is to layer your themes for reuse. So let's start with like a basic well-named theme.appName. And then we're going to add an attribute which is added after our min SDK. So we have a min SDK of, say, 19. And then we're going to add this attribute, which is actually added in 27. So at that point, Android Studio is going to complain at you something about API level errors. And so one way you can fix that is by copying the theme and then moving it to like a values v27. But now we're going to have multiple copies of the theme, which makes it hard to maintain. It's very easy for them to diverge if you want to change one. It's not great. So what we really want is to reuse as much of the theme as possible. So ideally, we'd had something like a mix-in. Like SAS has this, and it's a great feature, but we don't. What we do have is inheritance, which isn't great, but we can make it work by using heavy use of layering. Now, this is exactly how AppCompat and the framework is built. So it does work, it's quite verbose. So don't get scared when I go through these slides. So the first one, so the way I've kind of thought about this is to layer your themes on top of each other. So the bottom layer is going to be called your platform layer. And that contains only API-level specific attributes. So stuff like the window light navigation bar, that is specific to 27 and above. So at our root, we'd have a name which is our min SDK, so v14. And then we're going to create an alias called platform.theme.appName, which points to that. Now, later on, in each of the API levels that we want to override with, we're going to have, so in this example, it's v27. So we're going to create an override, platform.v27, and then reset that alias to point to that. You'll work out more in a minute when I'll show you the big diagram of why that is. But it allows us to have a single theme to inherit from that switches the implementation underneath, so it always works on the API level we're running on. The second layer is called our base layer, and that is where the bulk of your attributes are actually going to sit. Now, you should try to only have one of these, and this is where that reuse comes in. If we have that one layer in the middle which contains all of our attributes, so your default view style, colors maybe, text appearances, whatever it is, the bulk of what your themes are today are probably going to sit in this layer. Finally, we're going to get to the kind of top entry point layer called the theme layer. Now, these should be as simple as possible and only used for specific overrides on specific configurations. So one example would be in your night theme. If you wanted to just change a few colors, so the material, well, we'll go through this later, but material theme says you can have a different color primary in night. This is one way. You'd have one theme in one theme in value/night, and it would have 2 or 3 attributes in there, building on your base layer. So this, if we take a step back, the organization looks a bit like this, which looks kind of scary, but it does help you in the long run. It allows us to vary our themes both by the platform layer on the bottom layer, but also by configuration at the top, while keeping the majority of our reuse and our theme in the middle layer. So even if you're not currently varying your themes by configuration, say night, it's still a good idea to do this because you probably will in the future. And by doing it now, you're going to set yourself up for success. That's the third rule, layer your themes. And the fourth one is about kind of naming and splitting your resource files up. So I'm going to pick on the IO app a little bit here. And here's its styles.xml file. So you can see here at the top, it has its app theme. And then it also has its widget styles. And then it also has its text appearances. In fact, this file contains 60 style declarations in it. I think it's about 400 lines long, which is kind of impossible to, number one, code review, and number two, actually work out what's in there, just in case you ever want to reuse anything. It's because they've stuck to the rule of keeping each kind of resource type in separate files. So styles in styles.xml, dimensions in dimensions.xml, and strings in strings.xml. Now, that's not a bad idea, but what it means is that it quickly leads to huge files. So what I'd say to do instead is group them on kind of the logical kind of use of them. So themes and theme overlay should go in themes.xml. Type, so anything to do with type, text appearances, text size, dimensions, line spacing dimensions, whatever it is, goes in there. Styles should only contain your widget styles, literally only thing in there. And then you would, of course, still have your dimensions and colors and whatnot. So if you want to go even further and start grouping, sort of drill down into the more semantic types, you could do stuff like this. So material brings this idea of shape appearance into your themes and styles. So you could have all your shape in shape.xml. Anything to do with SysUI, so if you're changing navigation bar colors or flags or whatever it is, that could go in that file. Android Studio, and the Android view in particular, makes this really easy because it will group those files nicely across all different resource qualifiers and API levels. So if you have them all the same name and they're all logically trying to contain the same thing, you can easily see and try and drill down into the different configurations. Nick's now going to talk about materials and components.
Yeah, there was a lot of theory, so we're going to try and bring it home and show why this stuff is important with some examples. So material theming is all about expressing your app's brand. And it does that by having three kind of systems or subsystems of typography, shape, and color. And by varying these three dimensions, you can provide a really different experience. So while all of these applications are built using the same widgets, by providing different values for these different systems of color, type, and shape, you can get a really, really different look and feel to your application. So this is built heavily on theme attributes to make it easy for you to supply values for these systems and have the widgets pick up on them. Let's go through them. So the color system, hopefully you're familiar with some of these. They have the color primary, like your brand color in your application. Color secondary used to be color accent, renamed to secondary for kind of accent areas or some relief against primary. They have these variants, which is normally a darker shade for contrasting against those, like say the status bar, for example. But Material introduces some new ones which you need to be aware of. One of the interesting ones is color surface, which is the color of a background, like a card, for example, would use. Or as well as semantic names for things like color error. Interesting, Material also introduces these on colors, so color on primary, color on secondary, which are fully opaque colors which are guaranteed to contrast against their related colors. So for example, color on surface will always contrast against the color surface. So you then supply these, as we've seen so far, just like very, very simply using the theme attributes in your application, in your app's theme. And this will then ripple out to all the widgets which reference these theme attributes later on. Note here that I haven't supplied all the color system because I'm inheriting from the material components light theme, so that will provide sensible defaults for these. So for example, I didn't provide an error color or a surface color. I'll just use the sensible defaults that came from my parent. And then you can and should reference these throughout in your layouts. So here I'm using the color primary as a background on a view. I'd go be stronger actually and say that by default you should almost always be referencing theme attributes when you want to set colors in your views. If you're actually referencing a color resource or heaven forbid a hard-coded color, then it's likely a smell that something is going wrong there, and it's going to cause you trouble down the line if you try and support something like dark mode. A great tip is using these on colors in combination with the single item color state list trick that Chris talked about earlier. So say, for example, I want to draw a divider here. I can reference the color on surface and just provide a different alpha value here, 20%. And as such, this divider in the middle will get 20% black on a light screen and 20% white on a dark screen. So I don't have to provide two different colors where you end up with 50 shades of gray in your colors XML file and you never know which one to use. The next system is typography, which basically says to use a type scale, a semantic number of types, which you do by setting the theme attributes like this, and then referring to them similarly like colors. I'm going to go a bit quickly because we're running out of time. Anyone who's used text appearance might be a bit scared by that, but notice that a recent addition to material components is adding line height to text appearance, so you'll be able to set something like that soon. Then there's a whole shape system. It's awesome. You should use it. Basically introduces the idea of a shape appearance, which is a bit like a text appearance, in that it defines shapes as a family, so either rounded or cut, and a radius. And you then provide those using 3 different values for small, medium, and large components. So things like chips, we use the small one. Things like bottom sheets, we use the large color appearance. And I'm going to skip forward to something I want to tell you about before we run out of time. Yep, I know. Chris took too long. If you want to implement the material theming, then I highly recommend you check out this project on GitHub, which is Material Theme Builder, which will give you a template you can start from, which will define all these theme attributes. You can just change them to the values you want. And we're going to have to call it a day there, but the TLDR of this presentation is that if you understand the differences between themes and styles, you can wield them properly and use them to build maintainable applications which look awesome. So thanks very much.
Thank you all.